Hello friends, welcome again. Today again we'll be solving a problem related to electrical machine, and it's a question related to the induction motor. So let's start. It says that the machine has 4 pole and 50 hertz and it is a 3-phase induction motor with rotor resistance as 0.025 ohms and reactance as 0.12 ohms. And he's asking us what is the additional rotor resistance which is required such that 3/4 of the torque, 3/4 of the maximum torque is happening in starting. Okay, so the starting torque is 3/4 of the maximum torque. Okay, so let us first visualize what is the effect of inserting resistance. Okay, so uh, this is our torque slip characteristics. Okay, and say there is no resistance inserted. Okay, then it will have some characteristics like this. Okay, where this is s equals to 0 and this is s equals to 1. Now what happens when you insert some additional resistance? Okay, so two things happen as given in this graph. You will see that your maximum torque, okay, maximum torque is occurring at different slip. Okay, say earlier it was occurring at s1 and now it is occurring at s2. Now s2 will become more than s1. Okay, and another thing you notice here that the torques, the tau 2 and tau 1, which are the starting torque, tau 2 is greater than tau 1. Okay, so when we are inserting additional resistance, this is what is happening. Our maximum torque is happening at a higher value of slip. Okay, and also our starting torque is also increasing. Okay, so this is what we need to keep in our mind. Now here, to solve this problem, okay, you just need to remember this formula. This is tau over tau max is equal to 2 over s max by 2 plus s by s over s by s max. Okay, so this is the formula. I will read it out for you once again. Tau over tau max is equal to 2 over s max by s plus s by s max. Okay, so this formula, how it is beneficial to us? Okay, already we know that we require torque at starting starting with at standstill. So s equals to 1. Okay, already s is known to us. We need to calculate the s max. Okay, so if we are able to calculate s max, then the problem is solved. Now the maximum torque, okay, you can see the value of the maximum torque does not change, and the starting torque, this ratio tau over tau max, tau over tau max is given to us as 3 by 4. Already we know this. Okay, so we can insert this value and try to find out what is our s max. Okay, now let us proceed. So 3 by 4 is equal to 2 over s max by 1 because s is 1 plus 1 by s max. So now what you can do here, you can just separate out the terms. Okay, you can take the s max terms to one side. Okay, and you can write it like this. Now you see here that this will be a second order quadratic equation. Okay, so it is a equation, you can see it's a second order equation. It is okay, so it is s max 3s max square minus 8s max plus 3 equals to 0. Now this is a quadratic equation. Now what you can do is you can find the roots of this equation. Okay, so the roots of this equation are just by the formula we can find minus b is 8 plus minus under root b square is minus 8 square, which is 64, minus 4 into a, which is 3 into 3 over 2 into 3. Okay, over 2 into a, which is 2 into 3. Okay, now you can calculate this value, and what you can do is you can discard the plus sign, only you can take the negative sign. Okay, otherwise s max will become more than 1, which we do not want. Okay, so once you calculate this, you get s max is equal to 0.45. Okay, okay, so that is our s max. Now once we get our s max, we know that for max torque, okay, s max is equal to, okay, s max is equal to R2 over X2. Okay, so these are the rotor values. Now this is this is a relation which we already know. Okay, at S max this is what happens. Okay, now R2 dash will have the rotor resistance plus the external resistance which we want to insert. So let R2 dash is equal to R rotor plus R external. Okay, so when you put this value here and you put 0.45 is equal to R external is the value to be calculated, and R rotor is already given, and R external is to be calculated over this is 0.12. Okay, now what you can do is you can simply multiply it with 1.2 4.5, which you will get equal to 0.054. Okay, 0.054. Okay, if we cross multiply this one, this is equal to 0.025 plus R external. Okay, now from here if you subtract this with 0.025, you get R external is equal to 0.029 ohms. Okay, so this is the value to be inserted. Okay, this is the resistance value to be inserted, so that you get the 3/4 of the maximum torque at starting. Okay, so A is the correct answer for this question. Okay, so this is how you need to proceed with the problems like this. Just always remember this formula: S over S max is equal to 2 over, sorry, tau over tau max is equal to, I will write it again, tau over tau max is equal to 2 over S max by S plus S by S max. Okay, so this is how you need to proceed. Okay, so thanks for watching this video.